Hey, I'm going to do some calculus volume problems. We might get interrupted by a bell here, but let's see how we do. Number 5, find the volume of the solid whose base is the region bounded between the curve y equals x squared and the x-axis from 0 to 2, and whose cross-section is taken perpendicular to the x-axis, so we're cross-sectioning like this, are squares. So if I pull one of those cross-sections out, it's going to be a square, and the side of the square is that function, x squared. So I need to integrate. My volume is equal to the integral from 0 to 2. Should I put a pi out here? No, it's just the area of the cross-sections. Now, if you're rotating things around, then your cross-sections are circles, so you have that like pi r squared. But the area of this is x squared times x squared, or x to the fourth. And that's all you need to do. Number 6. Find the volume of the solid whose base is the region bounded between the curve y equals secant x and the x-axis from pi over 4 to pi over 3, and whose cross-sections are squares again. Alright, so let's see. Secant function is that like cosine function turned on its head. Something like that, right? If this is cosine of pi over 2 is 0, so that's where it would get an asymptote there. Now, we want to do between the x-axis and then between pi over 4 and pi over 3. So pi over 4 and pi over 3. If you wanted to know what the heights of these, it's actually not really necessary to do this problem, I think. But if you wanted to know, the cosine of pi over 4 is the square root of 2 over 2, so this is just the square root of 2. So that upside down. And then the cosine of pi over 3 is 1/2, so if you flip that over, you get 2. So my drawing's not terrible for a scale. Look at that. But that's not really what we need to know because we're taking cross-sections this way and they're squares. So my volume is equal to the integral from pi over 4 to pi over 3 of when I pull a cross-section out of this thing. This is secant x, right, the value of the function, and then so is this side. So the area is going to be secant squared x. So, what's the antiderivative of secant squared? You gots to know that. Okay, so I just need to know some trig now. So what is the tangent of pi over 3? That is the square root of 3 minus the tangent of pi over 4 is 1. So, not any simplifying that we can do there. Alrighty, number 7. What do we have here? Find the volume of the solid results when the region enclosed by the given curve is revolved around the given axis. About the x-axis. Sorry, not the given axis. So we're back to like pi r squareds now. So in 7, I've got the function y equals the square root of cosine x. Well, let's see. The cosine function, the square root of 1 is 1, and the square root of 0 is 0. So it still looks kind of like the cosine function. I guess when you take square roots of numbers that are less than 1, they get bigger, right? So maybe it gets kind of like bent up a little bit like this, but whatever, doesn't matter exactly, I think. Just need to get the sketch in here. So from pi over 4 to pi over 2, so this is the region we're going to be revolving around the x-axis. So looks like a bellhop bell. You know, you go into a fancy hotel where they have bellhops. You like ring a little bell, like ding, 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 ding. Hey, service, ding, ding, ding. One of those things. So what's the volume of this is pi, it's going to be a pi r squared, and this is that function. It's not hollow, so I don't have the minus the other radius, and we're just going from pi over 4 to pi over 2. So what's the antiderivative of cosine? The antiderivative of cosine is sine. And the sine of pi over 2 is 1, and the sine of pi over 4 is the square root of 2 over 2. Make sure that that's right. And there's that bell I was talking about. There's a pi on there. I forgot the pi. You should write that at every stage there. Number 9, we have y equals the square root of 25 minus x squared. That's the top half of a circle with a radius of 5. That's a thing you should recognize. And the line y equals 3. And we're going to revolve that region around the x-axis. So this is the point something comma 3. That's the line y equals 3. And if you do a little bit of math here, that y value has to be, or the x value has to be 4. And of course, negative 4 over here. Also, it's like a 3, 4, 5 right triangle, right? So the region enclosed by those two things is this. That's the thing that we are revolving around the x-axis. So this is going to be some kind of hollow, looks like a ball that's got a hole drilled through it. What is this? What a tricky one. I don't know. You'll have to let me know what you think that is. Alright, so what do we have? The volume is going to be equal to pi. This is like an r squared outside minus inside kind of deal here. So the outside radius is the actual function. Oh, and we're going from negative 4 to 4 as we take our cross sections this way. All right, notice that those numbers were not given in the problem. We need to figure that out. And the outside radius is the function. And the inside radius is just this constant. The inside radius is always 3. Right? That's the setup. I mean, that is so important to be able to set that up. And that is the... if you make a mistake after that, personally, I would be less upset about that. So the square root and the square, those cancel out, so I have 25 minus x squared. The antiderivative of 25 is 25x. Antiderivative of x squared is x cubed over 3. And the antiderivative of 9 is 9x. So that's really just 16x. I really want to simplify that. So I'm going to. 16x minus x cubed over 3 from negative 4 to 4. Alright, so that's pi times 4 times that's 64 minus 4 cubed is also 64 over 3. And then the, let's see, we're going to have two of those by the symmetry of this. You could set up the rest of it and do all the math and be careful with your signs and everything. But here, I'm just going to double this, because from here to here, 0 to there, is going to be the same as the other side. But you get the same answer either way, however you do this. I'm just being not lazy exactly. So let's see, 64 times 3 is 192 minus 64 over 3, so that's 128 over 3. 128 pi over 3, but I didn't multiply that by 2, did I? So that's 252, 56 pi over 3. Let's check that. Yep, that's the right answer. Great. Next is 19. Number 19. Find the volume of the solid that results when the, now we're rotating around the y-axis. Number 19, we have x equals the square root of 1 plus y. What does that look like? Well, the x equals the square root of y is the same as y equals x squared, right? So if you're trying to get a sketch of this, if you squared both sides of that, so it's the same as y equals x squared plus 1, right? But it's only the right half, because you are only going to get positive x values out of that square root. So it looks like that. And then the x equals 0 and y equals 3. And when y equals 3, this is at x equals 2. And that's this region. We're rotating it around the y-axis. So my volume is equal to pi. It is not hollow, so I'm just going from y numbers -1 up to 3. And I have the radius is the function, which is the square root of 1 plus y squared dy. So pi times the square root and the square cancel each other out. So the antiderivative of 1 is y, and the antiderivative of y is y squared over 2, -1 to 3. So I've got pi, it's 3 plus 9 halves minus -1 plus 1 half. I think I'm good there. Let's see. So I have 3 that's 6 halves, so I've got 15 halves plus 1, which is 17 halves, minus a half, which is 16 halves, which is 8, and then the pi. Let's check that. Yep. And next one is number 21. I have x equals cosecant y. Now, what does that look like? Well, if you inverted that, let's see, what does y equals cosecant? What does just the cosecant function look like? The cosecant function is the sine function inverted. So that's got an asymptote here, and pi over 2. So it looks like this. That's what the cosecant function looks like, because the sine function would be here. And where am I going in a pi for? So I think this is from 0 to pi here, and I'm interested in pi over 4 to 3 pi over 4. So I think this piece of it is going to be good. Now when I invert this, when I switch the x and the y, that just takes these asymptotes and makes them horizontal and does this. Right, so y equals pi over 4 to 3 pi over 4. And the region, what's the region we're looking at here? This is bound by x equals 0 and these lines. So it's this region here. So this is going to make, I think this is like a pulley, right? It's this round thing with this sort of groove in the outside. I think I have something that looks just like this. Hold on a sec. I think I used to have something. Where is it? Here. It's like this, right? All right. Now, where were we? So the volume of this is equal to pi times, this is not hollow, so just whatever the r is squared, and that is just a function, which is cosecant y squared dy from pi over 4 to 3 pi over 4. And the antiderivative of cosecant squared is negative cotangent squared. Don't forget your pi. Negative, you know what? I'm going to put the negative on the outside with the pi because I want to. And let's see, so negative pi times the cotangent of 3 pi over 4. The tangent of 3 pi over 4 is negative 1, and cotangent is just that upside down, so that's just negative 1, minus the tangent of pi over 4 is 1, so the cotangent of that is the same thing upside down, which is just still 1. So it looks like we got 2 pi. And check that. Yep. Okay, so where are we at now? Number 35. Find the volume of the solid that results when the region enclosed by blah 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 is revolved around the line x equals 9. Okay, so these are these revolving around other lines. So just need to shift things. So let's see, we've got y equals the square root of x, y equals 0, x equals 9, so that'd be the 0.93 right there, and that's revolved around the line x equals 9. Okay, notice that it is not hollow. So the volume of this is equal to pi times, where am I going from? I'm going from 0 to 9, right? Because I'm rotating around, oh, wait a minute. Revolved around the line x equals 9. X equals 9 is parallel to the y-axis. So this is a dy problem. So, almost made a mistake there, which means I'm slicing across this from 0 to 3, right? These need to be y values, not x values, because I'm slicing parallel to the y-axis. Okay, and then the function here, right, it's this, we have y equals the square root of x, but since it's a dy problem, I need to have it in x equals form. So this is y squared, but I need to shift that function because we're rotating around this, right? So this is the secret to these problems, is just to do a shift like you've always learned about shifts from pre-calculus, whatever. It's just minus, since this is positive here, we're going to do minus that shift. The College Board in their scoring guides, which you'll see some of, they like to put these the other way around, like 9 minus the y squared, but it does not matter which way you do it because we're squaring them. So I like to just do it like it's a shift because that seems consistent with other things you already know about. Okay, so what do we have here? Pi times y to the fourth minus 18y squared plus 81 from 0 to 3. Oh, that's not, I haven't done the integral yet, have I? Just foiled that out. And do some math, and then I got to get this in before the next bell rings, so I am going to duck out on you and tell you that when you do the math, that you should get 648 pi over 5. Find the antiderivative of that, plug those things in. That's 35, and then 37, last one. Find the volume of the solid that results when the region enclosed by x equals y squared. And x equals y. Those intersect at 1, 1. Is revolved around the line y equals negative 1. I'm going to erase that because it's not part of the region here. Revolved around y equals negative 1. Okay, that's y equals negative 1 is parallel to the x-axis. So this is a dx problem. So what does it look like? It looks like this. It's like a bowl that doesn't have a bottom. Don't eat your cornflakes in this bowl. Okay, so I got pi times, this is a dx problem, so I'm going from 0 to 1. Those are x values. And it is hollow. And there's a shift. This is going to be, since I'm rotating around this, the shift, it's going to be minus negative 1. So that's a plus 1 shift, right? The outside radius is this. Now they gave it as x equals y squared. In this, we have a dx problem, so I need that to be y equals the square root of x. So that's the square root of x. There. Okay. And then the inside here, this is just y equals x. So that's an x there. There is some algebra to do here, but that is set up right. And after you do all that algebra, you will find, you got to FOIL this out, right? This FOILed out is x plus 2 square roots of x plus 1 minus x squared plus 2x plus 1. So there's some things that cancel out and you can consolidate and whatever. But at the end of the day, you should get an answer of pi over 2.